The first talk this afternoon is a plenary talk given by Pralle Kriengwatana, and it's on music for animal welfare, a critical review and a conceptual framework. And I don't know if the slides are ready for this first online talk.
Hi, can you hear me?
No,
Hello?
the presenter is online. Hello, Pralle.
Hi, hi everyone,
Hi.
how are you?
Good to see you.
Good to see you too.
You're ready here to start your presentation
Okay,
on.
I think I'm already sharing my screen, but if I need to do it again, please just let me know.
Can you share your screen, please?
Yes.
Great.
Do you see it?
We see it now, and we see you, so all is good.
Okay, that's great. Well, thank you again for the introduction. And yes, my name is Pralle Kriengwatana, and I will be giving this talk on music for animal welfare, a critical review and conceptual framework. Thank you to the ISAE organizers for giving me this opportunity to present. It's actually a paper out already. And I'd also like to start by thanking my co-authors, Richard Mott, who I think will be presenting next, and also Carlton Kate for their contributions. I will apologize in advance if there is some background noise. There's construction in the building that unfortunately there's nothing I can do about. So apologies in advance. Okay. So the importance of animal welfare, here defined as a quality of an animal's life as it is experienced by an individual animal, is an issue that's globally recognized due to our coexistence and dependence upon other species for food, companionship, scientific and medical advancements, and education as well. So a lot of movement has been made to ensure animal welfare and improve animal welfare. And one of the means that's proved quite successful is enrichment. Sensory enrichment is a form, a subset of enrichment that includes a stimulation of the senses, including touch, sight, taste, smell, and sound. Thing is that compared to other modalities of sensory enrichment, it's not yet clear how we should be enriching acoustic environments. One of the most popular forms of acoustic enrichment is music. And a non-exhaustive search of the literature on the effects of music or the effects of components on music on animal behavior, physiology, brain, and welfare shows that there was a rapid and continued increase in the effects of music on animals since about the 2000s. Most of these studies have been done in mammals, especially rodents, but there are also a good number done in ungulates, mostly cows and pigs. The second largest category that's been studied is birds, and about 80% of these studies are in chickens. Basically, what I wanted to show you in this slide is that the scientific study of the effects of music on animals is a relatively young topic, but one that is likely to keep growing, especially as we search for simple and cost-effective solutions to manage animals and their welfare. And not only is there scientific interest, but there's also quite a bit of commercial interest. And here are examples of products and music designed for pets, saying that they're relaxing or good or calming. And most of these products are predicated on ideas that animals like music and music is good for animals. Unfortunately, these ideas are founded more on anthropomorphism and anecdotes than scientific evidence. And I'll give you an example of some of this mixed evidence of the effects of music right now. So let's take it from a very basic level, which is which sounds do animals find nice or pleasant? Which sounds might they like to hear? In humans, we will judge some combinations of sounds as pleasant, or in this case, consonant, while other combinations are judged as unpleasant or dissonant. I'm going to play you an example of a consonant and a dissonant sound right now. I'll play it on my phone because I realized that it may not work if I play it on my computer. So please let me know if you can hear it. So this first one is often, according to people who've listened to Western music, a pleasant sound. The second one is often perceived as dissonant. I hope you heard that. And there have been several studies looking at consonance preference in different species. Yet, from what you can see on the list here, only 3 of them have found evidence of consonance preference, and the patterns of which species would prefer them is not clear. So about 20 years and 200 studies later, we still don't even know if music potentially sounds nice to animals, given that consonant sounds are used a lot in music. So the example that I just gave you showcases one of the fundamental problems in the growing field of music for animal welfare, which is that we just don't know what properties of music is actually producing the effects on animals. To complicate things, there are additional problems, such as welfare goals being poorly defined. What I mean by this is that it's not clear what the music is supposed to do, what aspects of welfare it's supposed to enrich. For example, using music to enrich welfare for a lab rat probably means to stimulate them, while using music to enrich welfare for a dog in a shelter home may mean to calm them. So mechanistically, these 2 things are very different. So we need to really define what music is intended to be used for, not just a general welfare improvement. The second problem is that many studies compare the effects of music with a no music control group, without also including a non-music control group. So any other sounds, such as white noise. The problem with not having another control group is that if you just compare music and no music, the most parsimonious explanation is that adding sounds to the environment affected welfare, not necessarily music itself. The third problem is related to biased stimulus selection and reporting. So across studies, classical music is one of the most frequently used genres, and a noticeable portion of this category includes Mozart, and one composition of Mozart in particular, Mozart K448, which is a sonata for 2 pianos. I'll give you an example here. This is a review of music in rodents by Kuhlmann in 2008. And of all the classical music studies that they found in this literature review, you can see that over half of them are Mozart, and about 1/3 of them are Mozart K448. Sorry, it should be 448, not 488. And while, of course, it's useful to use the same stimulus to allow cross-studies comparisons, this really limits our ability to generalize to the effects of music to all other forms of music, and also risks pseudo-replication in that there might be something specific about this piece of music that's producing the effects in animals. So if we play them a different piece, we may not see the same effects. Moreover, there is a general problem with comparing genres. And even though, of course, this is well-intended, it may be a bit misguided because there's a lot of heterogeneity within genres. And what defines a genre is a concept that humans understand, but animals probably do not. The genre classification used in most studies is also based off of, it's pre-classified. So for example, if the playlist that you're using for the animals comes from Apple Music or Spotify, these are already kind of pre-categorized for us. And this is the categories that welfare scientists use. But it's not clear what acoustic parameters these record labels or platforms are using to say that this is a piece of pop music, whereas this is a piece of classical music. So again, genres it's a bit too wide and too vague, I think, to be used as a good comparison to understand what about music is actually producing effects in animals. Finally, another problem with stimuli is that many studies don't report enough information about the music stimulus. Sometimes they'll just call it radio music or the genre label of classical music. But as I hope I just convinced you, that's not enough information. You need to, I think, include as much information as possible. And with the bare minimum, which specific pieces were played, if they were played in the entirety or which portions were played, and also including how loud they were played. So these are just some of the basics, but as much as possible, I think is the best option here. The final and biggest problem that I alluded to earlier is that very few studies actually test how music works by investigating which features music actually produce these effects. So to get a better idea of how music can be used to improve welfare, one thing that we think we need to really do is to change how researchers are approaching this question in general. Change it from, we have a problem, let's see how music helps, to, this is what we know about how music works to improve welfare. Would it help with this problem that we're having? So how does music work? There are currently three main hypotheses. The first one is acoustic masking, the second is sensory stimulation, and the third is arousal modulation. And I'll go over each of these in a bit more detail in the following slides. So acoustic masking. This hypothesis proposes that music is good for welfare because it masks stressful sounds. What this implies is that animals don't actually need to perceive music as music at all. Music may simply be another form of noise that is less stressful and or more tolerable. Of course, acoustic masking makes sense, but it does have some problems, including that if it's masking these other background sounds, could it also be masking important communication sounds? We know that acoustic masking of meaningful sounds is one of the reasons why anthropogenic noise like traffic or construction noise might be harmful for wild animals. So it may be that music may also be detrimental for captive animals if it's masking the noises that they need to communicate. Moreover, we find that acoustic masking is probably not the only mechanism that's responsible for the effects of music on animals, because music produces different effects compared to white noise, and because different types of music produces different effects. So the second hypothesis is sensory stimulation. And this hypothesis suggests that music is good for animals because it increases the environmental complexity, so the richness of the acoustic environment. And this is often the case for things like lab rats or other, maybe perhaps zoo animals, where they're kept in environments that are relatively monotonous. Again, the sensory stimulation hypothesis makes intuitive sense, and it's clear that the auditory system is highly plastic, even in adulthood. So we would likely see differences in the brains of animals that were exposed to music and those that were not. Problem with this hypothesis is that it's a bit vague. For example, what does this plasticity mean for welfare? And what aspects of music contribute to the enriching effects of acoustic complexity? So that is not clearly stipulated in this hypothesis. The third hypothesis is arousal modulation, and it refers to a group of hypotheses that propose that music improves welfare because it can alter arousal and emotions, for example, excited versus relaxed. So this hypothesis assumes that human music with acoustic features that tap into sensitivities of a species' perceptual system or have been associated with particular outcomes might be able to induce emotions in other species. It's an interesting hypothesis because there is evidence that perception of arousal and features that encode it in vocalizations are conserved across different species. But there are still many questions. For example, emotional contagion is suggested to allow music to induce emotions, but I don't know whether emotional contagion occurs in animals if the sounds are not actually vocalizations themselves. So what we see so far is that these hypotheses need to be further developed. And we believe that this can be aided by knowledge of similarities and differences between human and animal music perception. So when humans hear music, we don't hear a collection of different sounds. We actually hear a sound as kind of one whole experience. And this allows us to do things like recognize melodies, even though their physical acoustic properties are different. And what I mean by this is that, for example, if you sing Happy Birthday in a higher key, like ah, or a lower key, we can still recognize it, even though that makes a difference. We can still recognize that it's the same song, even though the pitch is higher or lower. Again, I'm not going to play you the sounds because I don't think you can hear them, but I just had 2 recordings of Happy Birthday. played by a music box and one played by like a string ensemble. And again, they sound very different, but because we perceive music in a particular way, we can recognize that these two are actually part of the same song. Some of the components that we perceive in music include things like pitch, so whether the sound is a low sounding note or a high sounding note, things like rhythm, for example, kind of the cadence and duration of the different notes and how they kind of, and yeah, exactly how they fit in a pattern together. And the third is timbre. So the same musical note, C, can be played by a violin and a piano. It's the same note, even though when it's played on the violin, it sounds very different than it's played on the piano. Sorry. Okay. So then the question is, do animals perceive music as humans do? There were some initial studies that revealed tantalizing results. For example, in carp, which could learn to discriminate blues from classical music and were then able to classify novel stimuli from these genres to the correct category. Pigeons were also trained to discriminate several Bach organ pieces from Stravinsky's Rite of Spring, and they generalized this discrimination to novel parts of the composition or another piece from these composers. But when Bach was exchanged for Vivaldi, the pigeons started generalizing Vivaldi to Stravinsky rather than Bach. So this suggests that pigeons were attending to very different things than what people attend to in music. Moreover, across the several studies looking at pitch, timbre, octave equivalence, consonance, and rhythm, there are no clear patterns of what species are able to see because some abilities are shared with some species, but not others. So in short, there's a huge variation between different species in music perception tendencies and abilities. So given so much variation between species, can any generalizations be made about the effects of music on animal welfare? We believe so because there are some principles that apply across species, and the arousal modulation hypotheses are a good example of that. Recall that the arousal modulation hypothesis proposes that music with characteristics comparable to emotionally charged vocalizations can affect arousal similarly across species. And that is if the vocal features that signal emotional arousal are also consistent across species. And there is consistency in how arousal is, I suppose, encoded across species because of similarities in how vocalizations are produced and how emotional states can affect the vocal production systems. So for many vertebrates, including humans, the vocal production system consists of a source that produces a sound and a filter that modifies the sound. The source of the sound in humans is the vocal cords. So here I've shown you a picture of the vocal cords, open in calm speaking and closed in silence. And what happens when you speak is that you push air through the vocal cords, causing them to vibrate. And this is the source of the sound. But of course, the air, once it passes through the vocal cords, also has to pass through your upper vocal tract, which includes, for example, the space behind your tongue and the space right above your tongue and through the nasal cavity. And these can modify how it sounds. We can, for example, increase the pitch of our voice by increasing tension on the vocal cords. But tension on the vocal cords can also increase spontaneously due to arousal. So this is, for example, why people can sound squeaky when they get excited. The relationship between arousal and pitch is found across many species, which is why we can often recognize emotion arousal in vocalizations of other animals as well. There's also for the motivational structural rules proposed by Morton in 1977, which is that across birds and mammals, vocalizations produced in more hostile contexts are lower pitched and noisier as a way of orienting attention to indicators of body size. Advertising body size is a good way to avoid a fight, as larger animals are more likely to win a fight. The predictions of the motivational structural rules have been expanded upon by other researchers, but demonstrates again that there may be some principles connecting sound and emotions that could be conserved across animals. So how does music get under the skin? We have argued that perception is key to understanding how music affects welfare. So I'll just take you through some of the steps that how this might occur. So perception is the first step through which music can modify welfare. and there'll be major constraints on and interspecies differences on the perceptual sensitivity to various acoustic features. Then, once the animal perceives the sound, it has to assess it. And this assessment will modify arousal and assign valence to the stimuli, which will then affect how the animals respond. The small text that you see here are all the different, I suppose, modifiers of perception, assessment, and response, or the types of behavioral response. So after the response, animals can evaluate their response using public and personal information. And then this will feed back into how they, what they think of the stimuli when they encounter it again in the future. Ultimately, the entire process of perceiving, assessing, responding, and evaluating responses will determine whether and how music improves welfare. There are also, again, modifiers of these, including how much variation, how much individual variation there is to the responses, when music should be played, how much, how loud, how often, and also questions about variety to prevent habituation and agency and control. So it's clear that welfare goals, animal perceptual abilities, and music must all be considered together when studying how music can be used for welfare. And this is what we've proposed in our acoustic enrichment framework, is that the welfare goals need to be specific. We also have to consider what musical features animals can perceive and whether the music actually has these features that would allow animals to be affected by it. I want to take a few very last quick minutes to talk about the fact that music for animal welfare is interdisciplinary. Thus, not only do we need to understand the science side and the animal side of things, but we also need to understand the music side of things. And that we should be working with researchers in the humanities, especially musicologists, to understand how music affects animals. And I'll just give you a very, very quick demonstration. So most experiments looking at music for welfare have been using westernized music styles, but it's not clear why we are focusing on music Western styles. And this pertains to what features we think are important in music. One possibility that we focus on Western music styles is because it fits with what Western educated welfare scientists conceptualize as music and the values that they attach to it. For example, one of the main reasons people in westernized countries listen to music is for pleasure. So it's not strange for an animal welfare scientist to think that perhaps music could also induce pleasure in animals. But the types of sounds we find pleasant depends on several factors, including biological predispositions, experience, and familiarity with the music. We've talked about this about consonants as well, as how some sounds are perceived as consonant and others as dissonant. And although consonants and dissonance are thought to have biological origins, there is work showing that what the sounds that you hear in the music and the culture that you're exposed to affect your perceptions of consonance and dissonance. Statistical universals are basically features in music that are found across lots and lots and lots and lots of different music cultures, more than would be expected by chance. So these features that are considered statistical universals may be a good place for researchers to start looking at if they're trying to find out which aspects of music may affect animals. Musicologists can also contribute to choosing the right music for testing hypotheses about how music works. So for example, if the sensory hypothesis stipulates that music increases complexity in the environment, how are we going to measure complexity in music? Again, animal welfare scientists don't have a good answer to this question, but there is some research in humans about complexity perception in human music. So talking to welfare scientists would be a good idea here as well. Sorry, talking to musicologists would be a good idea here as well. Finally, musicologists can also help us understand the results and improve accuracy of interpretations. I will focus on this last part of, although animal welfare scientists are more interested in the effects of music on animal indicators of welfare and health, how animals respond to music also bears on how we see animals in relation to us and their value. So if we look again at this consonance preference, we see that the three species, rat, chimpanzees, and chickens, are the only ones that show preference similar to humans. What does that mean? Does it mean that chimps, chicks, and rats like music in the sense that they find music pleasurable or have an aesthetic appreciation of music? Would this make chimps, chickens, and rats equally sentient, more equal to humans, and more deserving of rights, or at least a higher level of protection and care than other species? These studies are mostly also done in only a few individuals, but resulted generalized across to an entire species. Of course, this is sometimes done in human studies too, but ethnomusicologists are more cautious in these type of interpretations, and working closely with musicologists again may encourage welfare scientists to find more convincing evidence of population or species level preferences. So that's my talk. Thank you for your attention. I hope you found it interesting. Again, you can read about the details of the paper. I've put it up here, and I would like to thank my funding and take any questions that you may have.
Thank you very much, and thank you for keeping so well in time. So now this plenary talk is open for questions. Have a question down here, and please stand up when posing the question and state your name and affiliation.
Hi, Jenna Kiddy from Dogs Trust UK. Thanks very much for a really interesting talk. My question is around vibration. Do you think that music can always be separated from vibration, and is it important to consider that? And I'm thinking specifically about purring in cats, which has been linked to healing, as well as the sound of that. Can that elicit the same feelings as that might be associated with healing?
That's a good question. I mean, music technically is vibrations, right? It's just we perceive it as sound because it vibrates our eardrums. But I'm not. I don't know too much about vibrations in more of the tactile sense than the auditory sense. And I don't know, for example, if you just turn music into vibrations, so we play it and we just touch, let's say, the speaker that's producing it, whether it would share features like, for example, rhythmicity, or like what's it called? It would or consistency is something like purring. So I think, yeah, it's hard to say because I don't think there's been much done on it. But no, it's an interesting possibility.
Okay, and we have another question from Bjørn Forkman.
Bjørn Forkman from the University of Copenhagen. I was just wondering, you could say, all right, so the problem is not the way that we do the experiments, but perhaps what the title of the paper is. So it's not music alleviates welfare problems, but rather that Mozart K448, was it? Yeah. Alleviates welfare problems. And if that's the case, is that a big problem? I mean, I understand it from a basic point of view that understanding the mechanisms behind it is important. But if we find that Mozart alleviates the welfare problems, can't we just use Mozart then?
Yes, but then there's also, it depends, I suppose, what is the welfare problem? For example, lots of welfare problems may be short-term, and perhaps Mozart will alleviate short-term welfare problems. But then there are also long-term welfare problems. Like I think, for example, a short-term one may be reducing acute stress. If you've got to handle the animal because it's going to the vet, or for whatever reason, you've got this acute stress, and there may be something about Mozart that's immediately calming, right? Or, for example, you could look at long-term welfare improvements in the case of where they expose rats to Mozart over a long time and shows that it increases, learning and cognition or something like that. I think that saying Mozart improves welfare, you first have to define what exactly is this welfare, and that's not being done. That's not being done enough. Welfare, I think, yeah, you have to be a bit more specific about what parts of welfare is the music improving. And yeah, is it a long-term improvement or is it a short-term improvement? Also, I think understanding how it works will also help us define other pieces of music might do the same, especially for something like long-term. Maybe the animals habituate to it. Maybe Mozart works for the first week, but after that, it doesn't work anymore. And then we're back to the square one. We don't know, we can't keep playing Mozart to the animals. So I think, yes, I think these studies that are being done showing that Mozart has an effect and this music has an effect, these are all really important. Right? I'm not saying that these shouldn't have been done. I think these are great, but I think we also need to dig a bit deeper so that we can pass some of these problems, such as habituation. We can create, we can really, let's say, create music that's targeted towards alleviating particular problems. Does that answer your question?
Yes, that answers his question.
Great.
Next question from the gentleman down there. Please stand up.
Mike Toscano, University of Bern. That's a question, more of a comment that you may have some interesting thoughts. I think this works really well. I would imagine it's fairly cheap, and particularly for large-scale animal housing, it's a way to spread out so all the animals are affected. So I just was curious if you see applications for this within large-scale animal housing, and then also the idea about creating these positive experiences as well. Yeah, I see lots of benefits, but you might have some comments.
Yeah, and I do. I think, one of the reasons music is used, and it is being used. You see lots of kind of news articles about, a farmer uses, let's say music for cows produce more milk kind of thing. So it is being used because it's so easy and so cheap and reaches a lot of animals at the same time. So I think there is a lot of potential for being to affect a lot of animals at the same time, and also potentially not only mitigate any kind of negative emotions due to, let's say, sounds from the background, but also perhaps potentially induce positive emotions. So yes, I think if we can find out what aspects of music or what components of music are really having a positive effect on animals, I think it has a lot of potential.
And we have another question down here.
Xavier Boivin from France. Thank you for the talk. After it, I have a problem. I don't know completely what is music, because you explained to us that even humans have a different cultural perception of music. And so we are always talking about music, but we are never defining it. I read a theory that in human welfare, the evolutionary advantage of music is the synchronization of the behavior of the humans because of the rhythm of music. So I would know what is your opinion about is, at an evolutionary point of view, music really important for this aspect of synchronization of the behavior of the individual, and is it applicable for animals, social animals, and social animals, and so that could change completely your view of what is music? Thank you very much.
That's a great question. Thank you. So there's two aspects here. It's true that even people who study music haven't really found a way to define music. So some would even say that that music is just something that we know when we hear it. But I mentioned statistical universals, and that again is things, for example, pitch and tonality and rhythm, that no matter what culture you're from and what you think music is, it's there. So even though we can't define music with, let's say, a nice clean definition, we do seem to be able to find components that are always in music. And so that's why I suggested that if we're interested in studying, let's say, how music works from a human to animal perspective, then starting from these universals might be a good idea, because if they're shared by all humans, regardless of culture, perhaps they have some sort of biological or innate component that animals might also share with us. The second question about rhythmicity, I think, is also an interesting one. There's a lot of work being currently done about rhythm perception in animals. The thing is that I think the question is then two-pronged. So first, can you perceive rhythm? And the second, you mentioned that rhythm in humans is used for coordinating social activities, then I suppose is whether you can entrain to the rhythm, whether, for example, you can perceive it, but then you can also move towards it, so you can act upon the rhythm. And this entrainment part, there's much less work on. Only a few animals have been found to be able to move with rhythm. Some of them are a lot of vocal learning species like parrots, but there's also been a California sea lion that seems to be able to bob its head with the rhythm. So it's an open question. I think we find limited, at the moment, limited evidence that animals can move in time with the music. So it's not clear whether animals also used it to coordinate social activities, even though they can kind of perceive components of rhythm, they may not actually be using it to coordinate theirs. That's what it looks like at the moment.
One last short question, please.
Okay, I'm Mustafa Farhar from University of Calgary. It is not a question, it's just wondering if the animal perception to music is different according to his emotional state, and if it is different also according like the environment he lives in, he lives alone or in group housing, something like this.
Short answer, please.
I'm sorry, I didn't quite understand what you were saying.
I said the animal perception to music can be different according to his emotional state.
Yes, I think so. So that's another part of this animal music for animal welfare that hasn't been well studied, is the animal control over music. Most of the time it's passive, so we just play music to animals and see what they do. But I think I also mentioned in one of the slides that agency is important. So having animals control what sounds they hear, because perhaps you're right, perhaps, you know, at one stage animals, they don't want to hear any music, or maybe they want to hear one music that's arousing when they want to be aroused, or calming when they want to be calmed. I mean, this is how music works for humans anyways, right? We might like a piece of music, but if you play it all the time, we're going to get sick of it and we won't want to hear it anymore. So one of the appeals, at least to humans, is that music is we play it when we want it.
Thank you. I think we need to end that. Please help me thank Priya for this talk.
Thank you very much.